A very good morning, friends. Today we'll continue lecture number 8 on application of derivative, which is based on maxima and minima. तो हम आज स्टार्ट करते हैं maxima और minima. So let us begin with definition. We'll be covering definition and then problems. Definition of maxima and minima. First, there are two definitions. First is what? First order derivative test. A function fx is said to be maximum at x is equal to a if number one, first order derivative at a is what? 0. Number two, f dash a minus h is greater than 0. And second is what? F dash a minus a plus h. Now, the meaning of this is what? F is increasing. First derivative is what? Greater than 0 means f is increasing at a for the value x less than a. Left side. And f dash a plus h is what? Less than 0. That is, f is decreasing function for right side to a. Where h is a small real number. Then a function fx is said to be minimum at x is equal to a if f dash a is 0. Number two, f dash a minus h less than 0. So that is, f is decreasing function for x less than a. And number three is what? F dash a plus h is what? Greater than 0. That is, f is increasing function for right side to a. So minimum के लिए right side पे decrease होना चाहिए, increase होना चाहिए, और left side में decrease. That is where h is what? Very small real number. H is second derivative test. A function fx is said to be minimum First, let me write maximum. Maximum at x is equal to a if number one, first derivative at a is what? 0. Number two, second derivative at a is what? Less than 0. A function fx is said to be minimum at x is equal to a if first derivative is what? 0 and second derivative at a is what? Greater than 0. So we'll start some problems based on this. First is divide number 30 divide number 30 in two parts such that their product is maximum. Let first part be x. Therefore, second part will be will be 30 minus x. Now, whatever we to maximize or minimize, that will take as our function. Let fx represent product of the two parts. Therefore, fx is what? X into 30 minus x. So fx is 30x minus x square. Differentiating with respect to x. F dash x is what? 30 minus 2x. For maximum value of fx, f dash x is 0. Therefore, 30 minus 2x is 0. So 2x is 30. X is 15. Since f dash x is what? 30 minus 2x. Differentiating again with respect to x. So f double dash x is what? Minus 2. So f double dash x 15 is what? Minus 2 less than 0. Less than 0 means fx is maximum when x is 15. That is product of the two parts is maximum when first part is $15 and second part is $30 minus 15 is equal to 50. Divide 20 into parts such that sum of their squares is minimum. Let first part be x. Therefore, second part will be 20 minus x. Let fx represent जो भी मैक्सिमाइज या मिनिमाइज करना है उसको फंक्शन ले लेते हैं. So here we are minimizing sum of their squares. So let fx represents sum of their squares. Therefore, fx is what? X square plus 20 minus x square. So fx is what? X square plus 400 minus 40x plus x square. 2x square minus 40x plus 400. Differentiating with respect to x. F dash x is what? 4x minus 40. Minimum value of fx. F dash x is 0. Therefore, 4x minus 40 is what? 0. So x is 10. Since f dash x is what? 4x minus 40. Differentiating with respect to x. So f double dash x is what? 4. So f double dash and 10 is also 4. And 4 is what? Greater than 0. So this implies fx is minimum when x is 10, that is sum of squares of the two parts will be minimum when first part is 10 and second part is 20 minus 10 is equal to 10. A wire of length 36 meter long is bent 36 meters is bent in the form of rectangle. Find its dimensions if the area of rectangle is maximum. Let me demonstrate it. This is wire of length 36 meter long. इसको बेंड किया to form a rectangle. अगर इसको ब्रेक करते हैं, so what we are breaking perimeter of rectangle. This means perimeter of rectangle is same as length of wire. Let x be length and y be breadth of rectangle thus formed. In this case, perimeter of rectangle is nothing but length of wire. Perimeter of rectangle is what? 2 into length plus breadth. And this is 36. So x plus y is what? 18. So y is what? 18 minus x. Let fx represent area of rectangle. So fx is what? Length into breadth. X into 18 minus x. So fx is what? 18x minus differentiating with respect to x. So f dash x is what? 18 minus 2x for max value of fx. F dash x is what? 0. 18 minus 2x is 0. 2x is 18. X is 9. Since f dash x is what? 18 minus 2x. Again, differentiating with respect to x. So f double dash x is what? Minus 2. F double dash at 9 is what? Minus 2 less than 0. So this implies fx is maximum when x is 9. That is, area of rectangle is maximum when its length is what? 9 meter and breadth y is equal to 18 minus 9 is equal to 9 meter. In such cases, length is equal to breadth. So rectangle is nothing but a square. जब लेंथ और ब्रेथ इक्वल होगा तो रेक्टेंगल क्या बन जाएगा? Square. A ball is thrown in the air. Its height at any time t is given by h is equal to h is equal to 3 plus 14t minus 5t square. Differentiating with respect to t, dh by dt is what? 14 minus 10t. For max value of h, dh by dt has to be 0. So 14 minus 10t, 10t is what? So t is what? 7 by 5. Since dh by dt is what? 14 minus 10t. Differentiating with respect to t. So d2h by dt square is equal to minus 10. d2h by dt square when t is what? 7 by 5 is minus 10 and that is less than 0. This implies h is maximum when t is 7 by 5. That is, height is maximum when time is 7 by 5 second. Now they want maximum height. Max height is what? H when T is 7 by 5. So 3 plus 14 into 7 by 5 minus 5 times 3 plus 98 by 5, 49 by 5. 5 LCM will 15 plus 49, 64 by 5, 12.8. Okay, 12.8 units. Find the largest size of rectangle that can be inscribed in semicircle of radius 1 unit so that two vertices lie on the diameter. This is diameter of semicircle. This is center C and this is rectangle PQRS. PQRS is rectangle. This is the radius of semicircle. Radius is 1 unit. Consider a semicircle having center C and diameter AB. Let PQRS a rectangle inscribed in this semicircle such that its two vertices P and S are on diameter. We will assume breadth has got Y, breadth has Y, and length has what? X. Let X be length and Y be breadth of We will assume 2x as length so that this will become what? X. Here we will take 2x as length. Let 2x when we are taking length as what? 2x, then this part will be what? X. Let 2x be length and y be breadth of rectangle. From the figure, x square plus y square is what? 1 square. Y square is what? 1 minus x square. Therefore, y is what? Root of 1 minus x square. एक क्लास है आज?
हाँ सर 10:30 को।
ओह, एक मिनट फिर स्टार्ट। Let fx represent area of rectangle. So fx is what? Length into breadth. Length is 2x and breadth is what? Y. Two x into y is what? Root of 1 minus x square. Now differentiating with respect to x. So f dash x is what? 2x. Derivative of this is what? Minus x upon root. Plus root into derivative of 2x is what? 2. 2 root 1 minus x square. Minus 2x square plus 2 into 1 minus x square upon root 1 minus x square. So 2 minus 4x square upon for max value of fx. F dash x is what? 0. So 2 minus 4x square upon root 1 minus x square. So 2 minus 4x square is what? 0. X square is 1 by 2. X is 1 upon root 2. X is positive because x is what? Length. Since f dash x is what? 2 minus 4x square upon so f double dash x is what? Or you can write this as what? Differentiating again with respect to x. F double dash x is what? 2 minus 4x square into derivative of this is what? Minus 1 minus x square raised to minus 3 by 2 into minus 2x plus root 1 minus x square raised to into derivative of this is what? Minus 8x. So f double dash at 1 by root 2 is what? This part will become 0 minus 8 by root 2, that is 4 root 2 into 1 minus 1 by 2 is 1 by 2 raised to half, that is upon 1 by 2 raised to half. So is equal to minus 8 root 2 will go up, which is less than 0. So this implies एक पेज ऐड करना होगा. fx is maximum when x is 1 upon root 2. That is area of rectangle when x is maximum area of rectangle is what? Two x into root of is equal to 2 into 1 by root 2 into one square unit. Thank you very much. There are no secrets to success. सफलता का कोई रहस्य नहीं है. It is the result of preparation, hard work and learning from failure. ये परिणाम है प्रिपरेशन का, तैयारी की, मेहनत की, हार्ड वर्क की और लर्निंग फ्रॉम फेलियर, असफलता से सीखने की. थैंक यू वेरी मच.